Hello, I am here to discuss variables in programming briefly, vaguely, and also to show you an application of them in VexVR. I'm making this for one particular student who was absent in my class this morning. These are actually my class notes from earlier. However, I'm going to put this publicly on YouTube for anyone who may benefit from it. Uh, Importantly, this is like an introduction to variables for like fourth to fifth grade students. So don't expect a whole lot of finer detail here if you're a comp sci student. This is just kind of like the rough basics. So I want to start with this illustration up here. I made this little illustration to hopefully sort of get our like wrap our heads around variables and how they behave. So I have a mailbox with a single letter inside of it, and I have labeled the mailbox as the variable and the letter as a value. So keep this in mind that variables always contain a single value. Variables typically have some sort of name associated with them. In this case, I said the name would be like, for a mailbox, it'd be like its address. So we have some particular variable that has been named, and inside it we can place a single value and it will hold that value for us. I made some notes here. I said variables, they have names, check. They store one value and only one value. So if you want it to store something else, which you can do, it will discard whatever value it had before and have the new value instead. Variables have to be assigned. So you cannot just use a variable you've made. You have named a variable and you have said, okay, I'm going to use this variable. However, you need to say specifically, oh, this variable is this big. It's this number. It's this thing, right? I have to say this variable is equal to 12. I have to do something along those lines before it can be used. And then I also said can have many variable, which is not English, but I think you get the idea. You can have more than one variable in your code. You can have, I don't know, sky's the limit, really, but probably not using all too many. Like I've used several variables at once in certain code, but yeah, you can realistically use as many as you need. So going over to VexVR, I'm actually going to get rid of these real quick, just so we can actually see how to make one of these. So if you go to VexVR, you scroll all the way down to the bottom. I'm using the free mode, by the way. There's no need to pay money if you're just trying to experiment with variables. I have, at the very bottom, if I scroll all the way down, I have these this logic variables section. And there's one variable that is already here to start. VexVR insists on having this at all times. We're going to go ahead and make a new variable. And we get to name our variable. Your variable's name can be whatever you want. Normally in coding, I say, hey, it's not a good idea to name it literally whatever you want, because you have to rewrite it, or you have to type it again over and over and get it correct each time you type it. And the more complex it is, the harder that gets. Now, we don't really have that problem in VexVR because we don't have to type it out again. We get to grab a block that has its name on it. But in general programming, you would like to have the name be simple. You would like the name also to represent, to some extent, what you are doing in the program, what that variable is supposed to do. So I would like to call this variable distance because it's going to be a measure of how far we're going. However, if you look here, it says distance. That keyword is reserved. That means internally, VexVR uses the word distance to talk about something else, and it doesn't want me stepping on its toes. So I'm going to go ahead and shorten it to dist. And notice I get a dist, like I get a new block. I made a variable. It's right here. I get a new block. I even have it show up in here so I can select between my variable or dist. I can also choose to rename my variable. Not something we do very often, uh, assuming it makes sense the first time around. Or, if you wrote your variable as something inappropriate and I force you to change it. You can also delete the variable if you need to. So we're going to make use in our code today of these two things. Of the set dist2. So remember I said variables have to be assigned a value. This is how we do that. And then this is the actual use of that variable. This is the use case. We take this, we plug it into different things. Don't do this, by the way. But we can plug in this variable wherever there could be a number. So wherever we see a number, we could choose instead to plug in the distance variable, dist variable. Now let's talk about playground. I think a good opportunity to use the dist variable, or to use variables in general, would be the static maze. So this is, what is this called? Wall maze. So not the dynamic wall maze. That is a little beyond where we're at right now. But the regular wall maze we could probably handle. So if I look at this wall maze, I see a clear path to the exit. This is the path I see. So looking at this, I have to consider the way I need to move through this maze. It looks like, it's going to be a relatively straightforward list of commands to our robot. Like, hey, move forward, then turn right, then move forward, then turn left, then move forward, blah, blah, blah. I want you to notice, though, how nicely everything is made into like these little like squares. So like, oh, here's a square, here's a block. You can imagine that this whole maze is just a grid. And because it's just a grid, the steps we take forward, when I say go forward, there's like specific amounts that we would go forward by, which is an excellent opportunity for our dist variable to shine. So we are going to use our dist variable to talk about how big of a forward command is needed to get our robot to move from the center of one square to the center of another. And if we can do that, we've simplified this problem pretty substantially. So I'm going to do a little bit of work first because it's hard to initially see if we have gotten the correct amount, right? So if I just have the robot move forward into this square, I may have a hard time, deciding, like, just with my eyes saying like, oh yeah, that's definitely in the center, that's not in the center. Earlier, actually, I thought that the correct number was incorrect because I just judged with my eyes, and I said, yeah, that doesn't look like it's going to work. What I'm going to do instead is I'm going to try and get the robot to here. So I'm going to have it do this, and I'm going to have it end here, because that list of commands, right, if I have it do this situation, and I have the distance that it's moving a little too big, the fact that I'm moving a little bit too much or too little again and again and again repeatedly would kind of be more visible, right? After I take a bunch of wrong steps, it's going to be a little bit easier to see. So I'm going to do this first, and then I'm going to say, hey, let's check and see if I have an appropriate distance. So I'm going to put this set distance to, or set dist to block here. I'm just going to set it to, like, I don't know, 200 to start. Who knows if that's right, but One is definitely not correct. I know that much. When I look at the path that I have decided I want to make the robot do, I notice it has some repeated steps. So we can make use of something that we've done before. I can take a look at the repeat block. And I can say, well, it looks like I'm just doing the same steps over and over. So let's take stock of what we should be doing. I need to move the robot forward, then turn it left, then move forward, then turn it right, then move forward, then turn it left, then move forward, then turn it left, then move right, or I'm sorry, turn it right, then move forward, turn it left, then move forward. So I have a list of steps that's repeated and therefore can use this repeat block. As a matter of fact, if you take a look down here, I started writing that out. So I said forward 1, left, forward 1, right. What do I mean by 1? I just mean one distance variable length, whatever that number may be. So I'm going to do exactly that. I'm going to say, let's go forward. Then let's turn left. Notice I'm using the turn left for 90 degrees. And then I will go forward again. And then I will turn right. So the 90 degrees, we want to keep those because 90 degrees is a very nice, like right angle turn. However, the distances, I want to be replaced by the dist variable. Stop, just stop. Okay. So this is a good little test for us to see if 200 is an appropriate length. Okay, the answer is clearly no. The answer is clearly no. So I would say now is a good time if you want to pause the video to participate on your own and to try and work with this variable to find a good number for our distance variable to get the appropriate path. Then now's a good time to pause the video and experiment on your own. And then I'll see you when you get back. So if you're here, I assume you either are not interested in participating in that yourself, or you have paused the video and you've come back. I'll go ahead and reveal the secret. It is 250. There you go. 250. And that puts us there. Oh, I put repeat 10. Oh my, how embarrassing. I'm going to leave that in though. One second. Okay, looks good. Actually, you know what? I want it to stay there because I want to talk about the next course of action we have. Okay, I'll pause it. So from here, now I need to consider what to do next. And this will be the last thing I do on video. I'm not going to show you the entire maze, how to do the entire maze. But I do want to show you how we handle this long corridor. So it looks like after the repeat block, after I've repeated those steps to do the little staircase thing, that I need to move forward, turn right, and then move forward again, but for a much longer distance. If we look at this once again as a grid, which I'll try to do, it's not the prettiest looking grid, but I'm trying. I'm doing my best. There you go. So if we look at this grid, the robot will be starting in this first square and have to move to the last square. So even though there's 4 squares, I want you to consider that it's moving just like 3, right? It's moving from the first to the second, that's 1. From the second to the third, that's 2. From the third to the fourth, that's 3. So it's moving 3 times as far to get to where it is at that point. So we need to talk about how that is done with the way we've set up our code currently. So first thing I will do, drive forward, turn right for 90 degrees, and then I need to get another one of the little variable blocks for it to turn forward. Grab another one right now because I know I'll need it. So for the go forward but for 3 times as long, some of you may consider doing this. You may say like, well, can't I just can't I just do this? And the answer is yes, you can. You can totally do this. It looks a little wonky because I'm pretty sure he like stops and starts at each one of these. Okay, so I mean, it looks a little strange that he doesn't go through all the way at once, instead kind of like stutter steps. That's fine, right? That's completely reasonable. I am going to show you a different way. I want to show you a way using the math operators. And this is the operator that allows you to, oh, I haven't paused this, that allows you to add, subtract, multiply, or divide two numbers. I'm going to come over to here to multiply, and I'm going to say I want 3 times the distance. Remember I said it's going for 3 times as long. It has to travel 3 times as far. So therefore, just saying, hey, triple the distance, that makes sense to me. Notice this thing has it's like an oval shape, and this is an oval shape. So even though they don't look like they would fit, the greater shape is what matters, not the size. It'll stretch to fit whatever it needs to. So let's take a look. Let's just verify that this works. Looks pretty good. Looks pretty good. So here's what I would say. Is it insanely difficult to write out the individual numbers instead of putting the dist variable, or 3 times the dist variable? No, right? Like, oh, the distance is 250, 3 times the distance, that'd be 750. You know, you can mental math that out. It's not terribly difficult for those who are somewhat math-minded. However, this is very clear. It's very easy to count to 3, much more easy than it is to count to 750 for some. And I can see what is going on. Oh, I have a distance, and this distance happens to be 3 times as long. That makes sense because I'm going 3 times as far. Okay, it all makes sense. Everything's kind of clicking. So this is a great way to make your code more readable as well. It's not going to be as hard for you to look at this next week and say, what is this doing? I don't understand why all these numbers are here. If you have this distance variable, maybe it's a little bit easier to digest. So this is what I am going to show you. I'm not going to finish the rest of the maze for you. However, you have all of the building blocks. You have all of the building blocks, and I will go ahead and give you the hint that, much to my dismay, no other repeat blocks are used to get to the end of the maze. As much as I would like to automate the process a little bit more, turns out that doesn't really work out, just based on the layout of the maze. So that's going to do it for me. I hope this was helpful. And yeah, comment if you have any thoughts. And as for the student that I'm doing this for, get well soon. I'll see you back in class.